Welcome to the new math class. Today I will explain you integers and their opposite. Basically, integers are whole numbers, but these whole numbers we can represent with positive and negative numbers. Integers basically is when we have with numbers without fractional part or fractional component. And we are going to divide the integers in positive, negative, and zero. But we have a special definition for zero. As you can see in this figure, we have the number line. The zero is in the middle. To the left, we have the negative numbers, and to the right, we have the positive number. That you have to remember because when you need to locate a number, you need to remember where is the number or where are the number. For example, any number to the left from zero, it's a negative number, and any number to the right of zero, it's a positive number. If the number is closer than zero, it's greater, but when it's far from zero, it's negative. For example, you can see that we have -3 and -2, but -3 is less than -2 because -2 is closer than 0. If you compare the distance between -3 and 0 and -2 and 0, -2 is closer than 0. Now, in the other part, that it's in the right part, that we have the positive number, we have 1, 2, 3, 4, and this number you can put it onto the infinite because the number line you can plot the numbers to both sides, to the negative infinite and to the positive infinite. Now, I'm going to give you some examples about ascending and descending numbers. For example, ascending numbers is when we count, for example, 1, 2, 3, 4, 5, 6, 7, 8, or from least to greater. Now we have descending number when the numbers is to, when we count, for example, from 5, 4, 3, 2, 1, 0, -1, -2, -3. So any number in descending order, it's less than the number that is next to them. Now, I'm going to give you some examples about integers in real life. For example, you can compare or you can find the integers in the thermometers. For example, here you have the thermometer is 10 Celsius, degrees Celsius. This thermometer is 2 degrees Celsius. This one it's -2 degrees Celsius and this one it's -5 degrees Celsius. So if you compare this thermometer, it's in descending order or from greatest to least. But if you see negative, you can do the question why -2 it's greater than -5. Yes, because if you locate these two numbers in the number line, you will see that -2 is closer than 0 than -5 because -5 it's far from 0. Now we're gonna move to the next slide. So here we have location. Many times you're gonna use a number line to locate the positive, the negative numbers. Remember 0, it's no positive, no negative. So here we're gonna use 0, we can call 0 the origin. And to the right, remember we had the positive number, and to the left we have the negative number. So now we are going to locate this number -5, 10, 5, 8, -3, -6, and 2. Pay attention with this location. For example, if you want to locate -6, we have from 0, we're going to move 6 units to the left, not to the right. It's to the left because it's negative, and we already have the -6. Now, if we need to locate -5 from 0, we're going to move 5 units to the left because it's negative. Now, if you need to locate -3, we're going to move -3 units to the left. And then you have +5. +5, you're gonna move from 0, you're gonna move to the right, and because it's the positive position. And now we have positive 8. From 0, we're going to move to positive 8. Now we have positive 10, and we're going to locate it in the right part from 0. Now, I'm going to explain you why negative 5 is less than positive 5. Because if you see negative 5 it's in the positive position. If you rotate the number line, negative 5 is going to be down to 0. That means that negative 5 is less than positive 5. Any number in the left part is less than the number that is in the right part. For example, if you can see 1 and 2, to the left we have 0 and 0 is less than 1, but to the right we have 2 and 2 is greater than 1. Now here you have, for example, negative 5, negative 4 and negative 6. Negative 5 is between negative 6 and negative 4. So negative 5 is greater than negative 6, but negative 4 it's greater than negative 5 because negative 4 is in the right part from negative 5, right and left. Negative 7 it's less than negative 5 because it's in the left part. Or for example, negative 10 it's less than negative 5 because it's in the left part from negative 5. Any number in the left part it's less than. Now we're going to write the opposite of some following integers. For example, look at this. Imagine that you have the integer negative 12. The opposite of negative 12 is positive 12. Why? Because we only change the sign. If this is negative, we plot positive. Now we have positive 34. What is the opposite? It's negative 34. Now we have 23. The opposite of 23 it's negative 23. Positive 5, the opposite of negative 5, it's negative 5. We have negative 8, and the opposite is positive 8. Now thinking in this, it's number 9, the opposite, it's negative 9. And we have negative 1, the opposite of negative 1, so it's 1. So this one, you can find the location of those numbers. So imagine that you have the number negative 2345. The opposite is going to be the same number but with positive sign. Or for example, you can relate with black and white. What is the opposite of black? It's white. So now you have to, if you have some doubts about this topic, so you can rewind the video and you can start again. Okay, so remember the location of the numbers: to the left are negative, to the right are positive, and 0 is the origin. 0 is neither positive or nor negative. Okay, so another review will be that, for example, if you have these integers, negative 12, positive 12, 34, negative 34, 23, and negative 23, and so on. Remember that we apply the integers in real life. For example, we can find in thermometer, because in this one we have the temperature is 10, the temperature is positive 2, the temperature is down to 0, so it's negative 2, and in this case the temperature is down to 0, that is gonna be negative 5. So this is the topic integers and their opposite. So I hope so that you can understand better these definitions. Okay, good job.